And so now I'm going to turn it over to the guy who seems to have cleared out all the snacks and I'm guessing is ready to go, and that would be Mr. Jim Davis. Can you take it away, Jim?
All right, good morning, everyone. Thank you for the introduction. Uh, let's get going. So we get a lot of questions about using an OTDR and when should I use an OTDR and how that works. And we wanted to go through a basic example today of using, this is our OptiFiber Pro OTDR. Here it says OptiFiber Pro. We can see that it is an OTDR module. It has a single mode port, a multi-mode port that we're connected to. There's also a visual fault locator here on the top. I'm going to talk about that later. Now, our task today is to characterize this link. It is our demo box. We have about 150 foot, a 50-meter link. It has an SC connector on both ends. Now, for the sake of time, I'm going to try not to spend these whole 15 minutes cleaning and inspecting fiber. I've pre-connected the first part of the link, so we'll take it away. You're going to be able to see me working on the screen here, and over there is just a computer connection to my screen to try and make this better. You'll see that we're set up to run a fiber inspector test. We're going to select that. We're going to select a new test. Because we have an OTDR module attached, it gives us a choice of OTDR tests. And this is a pretty simple link. 2 connectors, not a lot of distance. So I'm going to go with auto. I'm going to let the OTDR do absolutely all the work for me. If the OTDR is not able to figure it out, hey, then we might have to step into manual. So we will push test to start. Now, we can see that there are 2 connectors here. Very important, we're noticing that the quality of the connection is very good. We want that pegged all the way to the right. That's making sure that this port on the OTDR, is in good condition. If the window's dirty, it's hard to see out. Now, behind the scenes here is a trace. Let me go down to just 1 wavelength. And this trace is classic OTDR. The strength of the reflected event versus the distance to where the events are happening. Now, here is an expert module for the OTDR, and the expert module is showing, hey, it's about 50 meters long, so we're done, right? Well, kind of, except I don't know if this connector is good, and I don't know if this connector is good. Let's go back to that trace for a minute. Now, in the trace, if we zoom in here on the first event, whenever we go from one material to another, say in the case of the fiber, we're going from one piece of glass to another piece of glass, there's a little air gap there in the middle. And that change of the refractive index of the materials causes a reflection. So we're seeing that reflection here in the graph, and basically right here is what we call the dead zone. The OTDR can't see immediately at the port, so because I'm using this little short cable, I'm not able to see this first connection. Now let's go back to the event map, and we can see the end of the fiber here, but I can't measure that again because, let's zoom in on our end event, there's nothing afterwards. So if I have a problem like my home cable service breaks, I don't need to know the quality of this connection. I need to know the distance to where the fiber was cut. But since my job is to characterize this link, in order to see this first connector, we're going to have to use a launch fiber. Now, tried to make this a little bit like a cooking show, and I've done some work ahead of time on this. So we'll plug in on this end of the launch fiber. I'll put the launch fiber over there on the left. And let's hit test again and see what this does. Again, we're doing this in real time, so bear with me if something goes sideways. Now, as we're getting ready, we can see this first connector and we can see the end event. So we'll go back to our event map, and hey, there's our first connection. 0.33 dB of loss, entirely within the limits, minus 58 dB of reflectance. That's actually really good, but still I cannot see this last fiber. So if I want to see the last fiber in the link, this is very important. We get caught up on this a lot of times where people will use a launch fiber, but not a tail or a receive fiber. So I don't know what's going on with this last connector. Let me add a receive fiber. Now there's about 100 meters of fiber inside this convenient packaging. I really like the packaging for this. It is a practical size. If you've ever worked with 100 meters of fiber, 300 feet of fiber, not in this nice package, you know what I'm talking about. So now we're going to click in here, and I'm going to do something that's just a little bit fancy. We're going to go back to the home screen, and we're going to go into our test. We're going to edit it, and I'm going to turn on launch compensation. Earlier today, I plugged the two launch fibers together just to tell the OTDR how long they are. And the purpose of that is, well, you'll see in a minute when we run the test. Remember, I'm trying to characterize a 50-meter fiber, not a 100, 250-meter fiber. I don't want the length of the first and the last fiber included. So by setting the compensation, you can see that the launch and the tail fiber are grayed out. So dot 32, about the same as we had before. Now, because on the trace, we've added that tail fiber, we can see the second connection. Let's go back to the event map because that's pretty easy to read. And let's take a look at that second connection. Oh, 0.06 dB of loss. Boy, I must be really good at cleaning fibers. You know, that's almost too good at cleaning fibers. And now we want to talk for a second about bidirectional averaging. I don't want to go into too much detail, but because of a backscatter coefficient, different properties in the glass that's in this demo box versus the glass that's in this, the loss values can be skewed. Now remember, an OTDR isn't actually measuring the loss. I don't know what's coming out of the far end of the fiber. I'm measuring the light that's reflected back to me. And because of a change in the coefficient of backscatter, we get different amounts of light reflected back. So basically what's happening is there's more light being reflected back from this fiber than this fiber, which is giving us an optimistic result. So what we need to do to overcome that optimistic result is to run this test in both directions. So I'm going to save the test. We're going to call this conveniently labeled End1 for fiber 1. Click Save there. And now what I'm going to do is plug in the end of the tail fiber to and let me point out what I'm using here. This is actually a little bit interesting. I should have explained this before. What I've attached is something that we call a port protector. You might even refer to this colloquially as a sacrificial cord. Rather than plugging a lot into this, well, frankly, it's a little bit expensive. A high quality port on an OTDR costs money. We want to protect that. We'd rather sacrifice this cheap cord. Now, before I plug into this cheap cord, not that cheap, before I plug into this cord, we are going to do a little bit of inspection because this is real world. And I want to make sure that this connector is not dirty. So I don't have to change tips. I'm just going to use a bulkhead adapter on that. And let's look and make sure that fiber is still in good condition. This will just take a couple seconds here. Beautiful. That fiber is still in good condition. So now I'm going to take the tail cord and I'm going to attach the tail cord. So what was our tail or our receive fiber is now our launch fiber. And what was our launch fiber is now our tail fiber. Basically, we're going to shoot it in the other direction. And let's push test to start. We'll run through this. Again, this is happening in real time. Hey, it's good to see that my port quality, the quality of this port, is still pegged all the way to the right. That tells me that we're getting a good value there. Now, this is telling me end 1. I only have one end, but watch what happens when I hit save here. I'm going to switch to end 2 because we're coming into end 2. We'll say save. I'm sorry, we're going to screw up because this is live. We're going to run that test again because, Hey, I know you guys like to hear me talk, or at least I like to hear me talk. Sorry about that. So we're going to finish here, and now we're going to hit save, but we're going to change this to end 2, and we're still on fiber 1A. So we're going to hit save, and now here's a really useful thing. In order to accurately measure the first and last connector, we need a launch, a tail fiber, and we need to measure in both directions. This measurement in both directions is called a bidirectional average. And on board the tester, this has happened automatically. Here we have end 1 with the good connection and the really good connection. Now let's jump to end 2. Wait a minute, that .06 that I had has suddenly turned into a .19, and that other connector that had .3 something in loss is now 0.09. That's the optimistic end. But when we put them together, we get an accurate loss value for both of those connections. So let's click on home, and before we go back to the task at hand, let's sync this and send these test results up to LinkWare Live, because then I don't have to worry about losing them. We're going to sync this in real time. There it goes. And now, just for kicks and grins, I'm going to throw this webinar over to Adrian, who's about 50 miles away from me. Mark, can you pass Adrian the ball?
I am happy to do that. Just a moment, Adrian. Here we go. We're now the presenter.
And so what
always helps if I take myself off mute as well.
That does help, yes.
That does help occasionally. So yep, let me share that window there, and hopefully you can see my LinkWare Live account.
No, your LinkWare PC account.
My LinkWare PC account, that is correct. So like the last webinar, we are socially isolated. Jim is in a place called Marysville. I did a quick check this morning. There's no traffic. It would take me an hour to get to his house. So Jim has shared his LinkWare Live account with me. So remember, if you looked on that tester, you would have seen April 15, 2020 snack as the project name. Well, there's the project name. If I simply select that project name, I also get to see other projects he's shared with me as well. If I click OK, I've got 2 records to import. I can decide if I want to import them all, or decide which ones I want to import. In fact, I just want to import that 501A because that was the one where we had a slight hiccup on. So import selected items, and bam, here's my test report. So here is, you see everything that you saw on there. You can do your detailed OTDR analysis, you can do all your graphs, you can do all your analysis and everything else. Now this plays really well in the field, because if the operator is of limited skill and needs help interpreting the trace, rather than trying to use your phone and do a video and or what have you, by just pumping it up to LinkWare Live and then bring it back onto your PC, you can see what's going on. And in terms of the report is exactly the same as if you were to connect it to the tester or download it from a USB. So let me do a print preview. And here is our test result. Now, what I like about this, and taking a little bit more time here, is I call the first page the simple page. I think everybody could understand that. But we also appreciate that we have some OTDR folks, and they like to get all the gruesome detail. So what you can also do is get full page OTDR graphs at each wavelength. So there's something in there for everyone. So with that said, that's the end of our 15 minutes. Let's open it up to questions.
All right, we do have some questions. Thanks, Adrian. Thank you, Jim. And one of the first questions was, does the tester come with the shirt that Jim is wearing, because they do seem to match? Jim, any comments on that?
Well, that is the way that you can identify a skilled technician in the field. They will be not only wearing a yellow shirt, but they will not be wiping their fiber interfaces on it.
Very good. Yes, the shirt is not optimized for cleaning of fibers. Another question that's come in is that when you're testing multi-mode, do you need to use a mandrel when you're using an OTDR like this?
That's a great question, and I sometimes find confusion on the part of people where they misunderstand the difference between our 100-meter launch fiber and the test reference cords that we use to be doing loss testing. When we're doing loss testing, we talk about an overfilled condition, and we use a mandrel, or this puck, to get encircled flux compliant situations. So direct answer to your question, in the OTDR world, we are not going to use a mandrel. The standard does specify the requirement for encircled flux compliance at this point. What we have recommended and what we have seen people do in the field is to use the mandrel for the loss testing with our, this is about a 6-foot long test reference cord. Good question.
Okay. Another question that's come up is, so you did the testing at two ends. Now, of course, that was a lot easier since both ends were on the table. Let's say those ends were, I don't know, 10 kilometers apart. And let's say you wanted to test that cable in both directions. Would it be faster to have two OTDRs so that you could do the test in both directions and then average the results?
I like that idea of two OTDRs.
I bet you do.
That's a good one. Well, we were torn about doing a more sophisticated demonstration today. We have a cool feature in the tester, something that is called Smart Loop. And what we do with Smart Loop is we use a third launch fiber and we put that on the far end and we loop it back. So what we can do is shoot two fibers at once, one in one direction and the fiber coming back in the other direction. And then the OTDR will automatically cut basically that trace into two pieces. I didn't go for the Smart Loop demo in this simple example today because we start to get a lot of fibers. And the important thing about Smart Loop is to understand that you're testing the fiber in both directions without having to take your OTDR to the far end. Now, an important point on that about taking the OTDR to the far end, if you're not using Smart Loop, is I don't want to disconnect and reconnect the fibers because that may change the alignment of the fiber and change the measured value.
So the short and curlies are that is with the Smart Loop is you don't have to walk the tester to the other end. And also if the other end is say at the top of a turbine and a windmill generating farm, it's very difficult to get into that space as well. So I think that might suggest we have an opportunity of maybe doing another 15-minute one where we actually do the Smart Loop and show how cool that works.
Yeah, I think that would be a very good one. We could also show how, and Jim, I think you did a pretty good example here of showing how different the results can be depending on which direction you shoot. But when you average, you get a much more accurate result.
Yeah, and that is any OTDR, that's physics of the glass. That's how you get an accurate measurement.
Okay.
Actually, that is actually called out in the standards. The standards say specifically if the backscatter coefficient of the glass you're testing is not the same as your launch fiber, which is going to be most cases, then you should measure in both directions and take the average. Like Jim said, just to emphasize this is not a Fluke thing. This is an OTDR thing, and this bidirectional averaging issue is applicable to all OTDRs.
Okay. One other question. When Jim, when you were showing it, but I think Adrian, you can also show it on the report here. Well, in fact, I think it's right there. It says that the test passes. And can you explain a little bit about what that means? What is it passing?
Yeah, I can definitely take that one. This is we have multiple test limits within the tester, and the one that Jim selected here. Let me see if I can zoom in a little bit. Actually, you know what? Let's just yeah, I'll zoom in a little bit. Let me see how far can we zoom in. Oh, that's plenty zoom in. Here you'll actually see the general. It says general fiber RL 35 dB. This is just a generic test limit that you can use, or you can create your own ones. So in this case, the requirement here it's looking for, in fact, actually, if we go down into the event table here, we can see that the limit for a connection is a very high 0.75 dB per connection. And we're looking for a reflectance of better than -35 dB per connection. And you might be looking at that and going, wow, 0.75, you guys are crazy. Absolutely. You can put your own limit in here. So this whole notion of auto-passing, auto-failing is really no different to loss length testing. You get to decide what limit you want to put in here. And if you want to create a custom limit and drop that down to say 0.3 dB, then you can absolutely do that. Same with the reflectance. You can define your reflectance limit as well.
Now, Adrian, that 0.75 loss factor there for per connector, or is that? Yeah, that's per connector. That's a standards-based thing, is it not?
Actually, you know, in the revised standards, there's different values for. It's got rather confusing in there, but the bottom line is now that when you look at the TIA standard for multimode, that should be 0.5 dB now.
Oh, okay, but as you mentioned, you can change that. That's easy to do.
Absolutely, and the thing with it, particularly with OTDR testing, is you might be using splice on pigtails and what have you. So yeah, you'll be using your own test limits. So yeah, just want to emphasize that we have an automated test limit here today. We just picked general. We didn't want to pick TIA. We didn't want to pick ISO. Don't want to get into that. Who's better than the other? So we play neutral. United Nations here. And we just picked a general limit. But yes, you can enter whatever limit you like in there.
Yeah, so as a contractor, for example, you might be told what the limits would be by your customer, and then you can enter those in, and away you go.
Absolutely. And then you don't have to analyze every trace. You can just rely on the pass-fail.
Right. Okay. Well, we're getting a lot of questions today. I think OTDRs are a great topic. Here's one of the other ones is that, wait a minute, did I lose it? Oh, what will happen to the loss measurement if you have two different fiber types spliced together?
Okay, the loss is the loss. Now, what two fiber types are you talking about? If you splice multimode and single mode, not good. If you splice 50 and 62.5, also not good. But it may be inevitable that you have some older single mode fiber that's installed and you splice some similar construction, a 9-micron core single mode fiber, to that older fiber. Those should be able to work fine. This difference in backscatter coefficient doesn't mean one is better or worse than the other, even within the same model of fiber. If it's been drawn at a different time, it may have a slightly different backscatter coefficient. So we need to run that test in both directions to get an accurate loss value for where you've spliced those two different fibers together.
And that is extremely common. When we start looking at traces, not in the enterprise, but outside plant traces, when you actually look at the trace, you can tell where different fibers have been spliced in, because you look at the trace and you get a slight up, and then you see the downward slope of the trace, and then it drops down again. And so you can actually see it's extremely common. It's principally the reason why the vast majority of people shoot it in both directions and take the average.
Okay, good, thank you. And another question is, now I lost that one again.
No, here, I've got it. Is it true that to get a true loss reading, you should use a power meter and light source instead of an OTDR?
There is?
And the answer is yes, because I tried to point out, I'm not measuring how much light is coming out of the far end with the OTDR. I'm measuring what is reflected back to me. And we can infer from the OTDR about what the loss is going to be of a link. But for the most accurate measurement of what the loss value is, we want to have a light source on one end and a power meter on the other end to measure how much light is coming out the far end.
Thank you for catching that one, Jim.
Sure, team effort here.
This one's probably a question that would require maybe somebody to be able to go out and look at this in more detail, but maybe you could just give a general answer here. Is this customer says, we spent a lot of money on our OTDR tester, but every time we test, we get failures. What should they look for if that's what they're seeing?
New technicians. No. Boy, that can go in so many directions. Some of the first things that we look for, of course, are cleanliness. what is the port quality. We have a great tech support team, and they will ask you for the FLW, the Fluke LinkWare test result. And just as Adrian is showing us the results here on the screen, the FLW is very helpful for us, because when somebody says, hey, the Fluke failed it, which Fluke? What failed? You know, there's some things that are real simple. You might be plugging into the wrong port. You may be using the wrong test limits for the type of fiber that you're using, or you may actually have a problem. So that goes in a lot of directions. To save us having to go out and visit you, again, send us that FLW, and that will help us to be able to understand what the nature of the failure is. Again, I'll say let's start with cleaning and make sure we have a camera, even a handheld microscope to check the fiber end face, and a cleaning kit, because that's going to be the first step.
Yeah, I will just back up Jim on that, is that when you come to OTDR testing, particularly with the reflectance, your less than perfect cleaning practice that you got away with using a power meter and a source really start to show up when you start looking at reflectance. But as Jim said, is absolutely get that LinkWare file, send it to support@flukenetworks.com, and we have a great team there, and they'll be able to analyze it and give you some pointers as to why it's failing and what the possible causes are.
Thanks, Adrian. Yeah, another question we've gotten, and then this is true, I think this can be kind of confusing. It says, like, you guys sell a lot, I'm going to paraphrase the question, but you sell a lot of different OTDR modules, and they can be kind of confused about, you know, which is the right one to buy for their application. And let me answer that one. I think the best opportunity there, or the best approach, is to, you know, talk to either your local person, or give us a call on the phone and talk to our experts on the line. And if they can't figure it out, well, they know who to go to figure it out, and they can usually get you an answer pretty quickly about you know, which is the best model for your application, because sometimes it's not always completely clear. We have different models that mix different wavelengths together that in general are designed to address most people's applications. But if you're doing something a little bit different, it may not be quite as clear, and you might want to have a little bit of advice from us on how to make that choice. Any other comments on that?
I don't know if Adrian can show us the where to buy page from the flukenetworks.com. That will help you to find your local representative, and they'd be happy to talk you through. It's not just the different models and do you have single mode or multi-mode, but also we're going to talk about accessories. What type of connectors are you testing? We don't, as a standard, include a launch fiber with an ST connector in it. So there's some accessories that you might want to add in. You may already have a camera and not need a camera or an inspection solution. You may be just looking for a standalone module. And again, we've got some reps that are pretty well trained, and they would, I'm sure they'd be happy to work through with you based on your use model, what are the best solutions for you.
Yeah, I'll just echo what Jim said, and this has been a problem. I've been doing this for 30 years. It's the most common problem is you get to site and you find out the connector is not what you thought it was, and you don't have the right launch fiber. And so what do? You make do. You find a short patch cord and you put it on the end of that launch fiber. The problem with that now is you're not measuring one connection anymore. You're measuring two connections. And then you start getting false failures. So yes, the one thing I would really emphasize in OTDR testing is absolutely make sure you know what connector you're going to be testing, and make sure you have a launch and a tail fiber for that specific connector. Don't be adding on patch cords to change the connector to the one that you need.
Okay. Let's see, we get another question thrown in here. If a link fails the testing based on EIA and TIA spec, can it still be usable if the total loss measured by a light source power meter is less than the maximum loss allowed by your transceiver, or in other words, the limits, the application limits, I should say?
Oh, that's a really good question. Really good question. and the reason why I say it's a really good question, because it's a touchy point. What you're talking about here is the difference between holding the contractor to workmanship and his specification and whether the application would work. So in the short and curlies of this is is the application is based on worst case scenario, maximum length and loss of so many connectors. So if you have a shorter link, then you're not going to get so much loss in that link. But you could have higher loss in the connectors and it still meets that application requirement. So what is the story there? Well, the story is the application will work, but your contractor has not met the requirements for that installation. And the other thing that gets a little bit touchy as well is if you start concatenating fiber links, that's when you're going to start having problems.
Right, or I'll add in, Adrian, another thing that can happen is if a couple of years down the road, you decide to go for an application that requires tighter limits and you don't really know whether or not you can meet those, that's when you can run into problems as well.
Yeah, but like I said, is, you know, if we look at that link in front of us, for example, and we assume that the total loss of that link is, I don't know, half a dB maybe, and the application requirement is 1.5, then it will work all day long. Think about this. That suggests that maybe those connectors in there could be, say, 0.8 dB, 0.7 dB each, and that application would still work. But the specification that you're installing to is not 0.7. So really what this is about is holding the design. The design of the cabling system has specified a loss of those connectors because the designer knows what application he's targeting. So it's really important not to just go like, well, you know, a gig requires 3.5 dB, so as long as it's less than 3.5 dB, then it's good. That's a very dangerous game to play.
And I've seen that now in the single mode world where the reflectance starts to become an issue. We've got a couple cases where the reflectance, I'm sorry, the loss was acceptable, but the reflectance was not. And on those very high-speed links, the bad reflectance screwed it up, and it was only using an OTDR that they could see that this reflectance value here was not acceptable for the application they were trying to run. Hey, I know that we're way past the time, and if you've run away, please don't worry about it. We're out here, and I think we're going to save some of these questions for next week's webinar. There were a couple that I wanted to explain a little bit more slowly here, real quick before we go. And the first one is this port protector cable that I'm using. The port protector cable is just a short SC to SC connector and a bulkhead adapter so I can switch from one end to the other. Now, another question that came up was how was it that we did the inspection of that? And so I have a camera, and this camera has a single fiber adapter tip, and on the end of the single fiber adapter tip I have a bulkhead inspector for SC connectors. So see if I can get that to go back on. And the reason I happened to inspect it through the bulkhead instead of directly was absolutely just for convenience. It was faster to have this camera just with one tip and not switch back and forth. Actually, what I had done is I have a second camera here in case I needed to inspect directly. And the final question was about the loopback testing or the smart loop testing. In a smart loop test, we would have a launch fiber that will go out. On the far end of our link, we're going to have a loopback fiber that will plug into both fibers here. And then on the near end, I would plug in my third fiber to be a tail fiber and then a launch fiber as we switch. So I'm getting like 50 beeps here, and most of them are saying, hey, we're getting way past the time. Folks, thank you very much for coming and listening in. And again, please feel free to reach out to us, info@flukenetworks.com. We would appreciate knowing what kind of topics you would be interested for us to talk about, questions that you have. We'd like to make these short and interesting. I did also want to point out on the flukenetworks.com webpage, Here's where to buy and find a reseller if you have a question for your local people about OTDR or other Fluke testers. And with that, I think, Adrian, any
Jim,
go ahead.
just a couple wrap-up things is, we did get a lot of questions, and I apologize, we really have run out of time to get through all of them. But as I mentioned at the beginning, we're looking for more topics to talk about. It sounds like there are other topics around this. So keep your eyes open, and we will be holding another webinar here in the next couple of weeks where maybe we can delve into some more of these more detailed topics around OTDR and fiber testing. The second comment I wanted to make is that, an OTDR is a pretty significant investment, and I would really recommend that you call us up and talk to us about this stuff. We've actually got people, if you call us on the phone, you'll actually get to talk to people who know what they're talking about. We don't have a bunch of call center people that don't know the difference between an OTDR and an OLTS, and they can really help you make sure that you get the right thing, no matter where you order it. Where you order it, that we don't care so much about that, but we do, that's your decision, but we do want to make sure you get what you need. The last thing I'll point out is Jim very conveniently left this up on the screen. We are running some great deals on some of our fiber optic testing solutions, including OTDRs. So if you do go to our homepage, you might want to check out the deals that we're offering right now, because some of them are really substantial. So you can get some great deals right now. Between now and June, you'll be able to get great deals. So with that, I think we're going to turn it back over to letting the rest of you go back to work or whatever you were doing before you got here. Keep an eye out for our upcoming events. And remember, if you attend 4 of our events in the months of April and May, we're going to enter your name to win our microscanner PoE, which is a great little cable and network tester to help you get PoE installations done faster. So
Probably
thanks.
a subject of a later, and we'll have to make that a subject of a later snack size webinar to explain.
Yeah, here's what you're going to win. All right, so thanks everybody. Have a great day.